Hello everyone. In this presentation I will talk about assembly language, one of the programming languages most important in the history of computing. Although modern languages like Python currently exist, Java and C++, all programs end up being converted into instructions that the processor can understand. Assembly language is one of the closest forms of communication between software and hardware. What is assembly language? Assembly language is a low-level programming language that allows direct control of the processor's operation. Each instruction written in assembly corresponds to a specific operation executed by the CPU. Thanks to this, programs can be very fast and efficient. Its main objective is to provide direct communication between the programmer and the computer hardware. History of assembly language. Assembly emerged during the 1940s and 1950s, when the first computers were beginning to be used, before its creation. Programmers worked directly with binary codes composed only of zeros and ones. Assemble greatly facilitated programming by replacing long sequences of numbers with easy-to-understand instructions. For that reason, it is considered one of the first programming languages in history. Code used in assembly. Assembly language uses simple instructions known as mnemonics. Some of the most common are MOV, which moves data between registers, ADD, which performs additions, SUB, which performs subtractions, and JMP, which allows jumping to another part of the program. These instructions are translated by an assembler into machine code so that the processor can execute them. Processor registers. Registers are small storage areas located inside the processor. They are extremely fast and are used to store temporary data. In calculations, some classic registers are AX, BX, CX, and DX. Understanding how registers work is fundamental to understanding assembly language and the internal workings of a computer. Advantages and disadvantages. Among the main advantages of assembly language is its high execution speed, efficient memory usage, and direct control over the hardware. However, it also has some important disadvantages. It is harder to learn than other languages, requires more time to develop programs, and the code is usually more complex to maintain. Modern applications. Although many people think that assembly language is no longer used, it is still important today. It is used in embedded systems, RAID, microcontrollers, operating systems, and device drivers, medical equipment, robotics, and cybersecurity. In these areas, performance and efficiency are fundamental. Assembly language in the automotive industry. The automotive industry uses increasingly advanced electronic systems. Modern vehicles have computers known as ECUs, responsible for controlling functions such as the engine, airbags, the ABS system, and electronic steering. Although much of the software is developed in C or C++, some critical functions still use assembly language due to its speed and reliability. Fun fact: an interesting fact is that all these programs we use directly, including video games and web browsers, operating systems, and engineering programs, end up becoming instructions that the processor executes through machine code. In other words, assembly language is still present behind practically all modern technology. Conclusion. In conclusion, assembly language is a fundamental tool for understanding how computers actually work. Although simpler languages to use exist today, assembly language is still important because it offers a deep knowledge of hardware and continues to be used in critical systems where speed and efficiency are essential. Thank you very much for your attention.